All right, let's practice naming some of these double bonded compounds. Starting with A. I'll just bring it down here. We'll name it down here. A says that we've got, I would draw these out. These are really hard to read, but we've got 1, 2, 3, 4, 5 carbons. So 2, 3, 4, 5. Looks like we've got a double bond between 1 and 2. Oh my goodness. Good enough. We've got, okay, 1, 2, 3. On the third, we have a methyl group. And on the fourth, we have 2 methyl groups, it looks like. Okay. So the first thing that we want to do here is we want to number our chain. That's like always what we want to do. We want to number our chain. And in this case, we want to give the highest or the lowest locant, so the highest priority for numbering, the lowest locant to our ene, to our double bond here. So it looks like we're going to start here. It's a pretty good place to start. 1, 2, 3, 4, and then we'll pick one of these, 5. And we're looking for the longest chain still, so we want to be careful and make sure that, one of these wouldn't give us a longer chain, but they're all 3 methyl groups, so that's pretty good. We're not going to get a longer chain there. All right, so we said 1, 2, 3, 4, 5 in our chain, so that'll be pentene. Remember, we've got that ene ending. We also have our ene, and we're going to give it the lower one, so we're going to give it to the 1, so 1 ene. And this is just my list. This is how I name things. And we've got a 3, and we've got 4 trimethyl. So we can put all this together. Make sure I didn't forget anything. Let's write the name down. All right, so I would say that we're going to put our ene towards the end. That doesn't get naming priority in like alphabetical, even though it's higher than methyl or alphabetically higher than methyl. It's going to go towards the end by our ending or suffix. So we're going to say this is 3, 4, 4 trimethyl. And we can say this is 1 pentene. We can say this is pent 1 ene. Pent 1 ene. Or we could just say this is pentene, because it's understood if there's no number that it falls on the 1 substituent or the 1 carbon. So these are 3 ways that you can name that ending. The trimethyl will be the same. The 1 pentene, the blue is 3 different ways to say the same thing. And I'm going to check it just to double check my work here. They go trimethyl, they do 1 pentene. But like I said, you can name it a couple different ways. They're all correct. All right, I'm going to erase this and we'll look at B. Okay, for B, I'm going to draw the structure out again. We've got 1, 2, 3, 4, 5, 6, it looks like, carbons. So 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Looks like the double bonds between the 3 and 4 carbon on my numbering. This is just arbitrary numbering here. 1, 2, 3, and 4. So I would say it's about right here. And then on the 4, we have a methyl substituent. And I believe that is everything. Double check. I've got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I've got a methyl, I've got a methyl, and I've got a double bond and a double bond. Okay, that looks good to me. Now I'm going to start naming and numbering. So remember, we want to try to give our ene the lowest number locant. So we could number from left to right. 1, 2, 3, 4, 5, 6. Or we could number from right to left. So that would be 1, 2, 3, 4, 5, 6. In this case, we have a tie. So we're going to look for some other way to break our tie. And that other way is going to be this methyl group right here. We want to give it also a low substituent, and it looks like when we come the blue way, we get it on 3 instead of 4. So we're going to number the blue way. So let's erase our red marks. And now we have our numbering. I've got 6, so I've got a hexene. I've got 3 methyl. And I also have 3 ene, right? Because they're on the same thing. And we always give this double bond that lowest locant number. Okay. So let's name this one 3 methyl dash, again, we can say 3 dash hexene. We could say 3 methyl dash, or not dash, 3 methyl hex dash 3 ene would also be correct. In this case, we have to show the number, so those are the only 2 possible correct ones. So again, these are the same, so are these. The yellow didn't change, the blue are the same way of saying, or 2 different ways to say the same thing. I'm going to double check my work again, and they say 3 methyl, 3 hexene, so that's good. All right, let's do C. So C, we've got 1, 2, 3, 4, 5, 6, 7, 8 carbons. So 2, 3, 4, 5, 6, 7, 8. And I'm going to number these arbitrarily. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Double bond is between the 2 and the 3 carbons. So 1, 2, 2 and 3. And there's also 1 between 5 and 6. So that's 3, 1, 2, 3, 4, 5, 6. So 5 and 6 would be right here. I have a methyl on the 7. That would be here. Oh, come on. And I have 1 on the 4. So 1, 2, 3, 4. Now again, those were just arbitrary numbers that I could use to draw this molecule. Those are not how I'm numbering this necessarily. I'm going to look at where my enes are, my substituents are, all that good stuff. The first thing I look at is where are my enes. I have 1, 2, 3, and I have 1, 2. So I'm probably going to number it this way, but I'm going to just draw this out and double check. 1, 2, 3, 4, 5, 6, 7, 8. And I'll number it the other way just to make double check. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So on this side, the red side, I've got 2 as my substituent, my locant for this bond. And on the blue side, I've got the 3. So it looks like red is better. And I don't have a tie between methyls, so I don't need to look at my substituents necessarily. I'm just going to take my lowest ene group. I'm going to go ahead and erase the blue because I don't need them anymore. We're going to number by red. And now I can start listing. So I have 8, so I have an oct ene. And I've made sure my longest chain is indeed the longest chain, so that's good. I have a 2 and a 5. Remember, we're going to give it to the lowest, not this one. the lowest locant number. So 2 comma 5 ene this time. I have a 4 and a 7 methyl, 4, 7, and we're going to call that dimethyl because there's 2 of them. And that's all I see. So now I can say this is 4 comma 7 dimethyl, and I could say 2 comma 5 octene. I need to put a dash there. Octene, or 4 comma 7 di, remember to put your dashes, dimethyl, and I could say oct 2 comma 5 ene. I'm going to double check my work here. They call it 4,7 dimethyl 2,5 octadine. I guess I need to put octadine. I don't feel like Dr. Hill would count that completely wrong. Because what, isn't it octane? Yeah, I think this is plenty fine. I've never seen it called octane before, so I don't know why it would be called octane, octadine. So anyway, I believe these are fine. Okay. And let's look at D, the last one here. Okay. All right, so for D, we've got 1, 2, 3, 4, 5, 6, 7, 8. So 2, 3, 4, 5, 6, 7, 8. And we looks like we've got 1, 2, 3, 4, 5, 6, 7. We've got a bond between the 4 and the 5. So 1, 2, 3, 4. That looks like about right here. And at the 6 carbon, so this is 5, so 6, we've got a CH3 coming off, and we have a CH2CH3. So like that. All right, now with this one we have to be careful. There's a lot going on here, and our longest chain may not be obvious. So let's number it from the left to right, just to start. Why did I put a 3 there? Okay, but what if we went up instead and said this was 7, this was 8, and this was 9? We get more. So this is the proper pathway to get to 9. So I'm going to erase those, and now we have our longest chain. And now we just need to figure out if we've numbered it correctly or if we need to number it from right to left. So let's go from right to left too. So we'll just do 1, 2, 3, 4, 5, 6, 7, 8, 9. And because we've got a tie here, actually, do we have a tie? No, we don't. We have blue 5 and we have red 4. So we should number it from the red side, because I know this is a little bit messy. Let me erase all of these except for the one around the bond that we're actually worried about. So if we look at blue and we're coming from, well, let's look at red first. If we're looking at red and we're coming this way, and we're looking at blue, we're coming this way technically, but I'm just gonna make it come from this way because it's easier to visualize. We get to 4 first, so red ends up being 4, whereas blue we get to 5 first, so blue ends up being 5. So it would be better to label it from the left to right so we can get 4 for the lowest substituent. All right, so let's just erase my little notes here, and let's go back and number it from left to right. Okay, and we have nonane or nonine, and we have that 4-ene, and then it looks like we have a substituent on 6, right? 6 has an ethane, sorry, or an ethyl, and 7 has a methyl, 7-methyl. And so now we can name this. We'll put these in alphabetical order. So we'll go 6-ethyl, 7-methyl, and we have 4 nonene, or you could say all of this non-4-ene. However you want to do it. Let me check my work, make sure I've got this correct. 6-ethyl, 7-methyl, 4-nonene. They have 6-ethyl, 7-methyl, 4-nonene. So we're in business there. So that's a little bit on naming. Remember, if they give you this kind of funky way of describing a molecule, redraw it and just give it an arbitrary numbering. That way you can make sure that you get everything in the right position. I'm doing this one and pointing to this one. So just making sure that you can get it in the proper position, that you're numbering it so that you can draw it correctly. And then go back and number it for real, making sure that your lowest locant is given to your ene, and then your longest chain is found. If there's a tie, we can look at other substituents and then see what those substituents, if they're better off from the left or from the right. And then just going in and numbering our chain and then finding where our substituents are, making a little list, and then compiling that list based on alphabetical priority.